Hello guys, in this video we're going to look at the third page replacement algorithm, that is least recently used. Now in our previous video we learned about optimal page replacement. In that algorithm we used to look into the future to make a decision about which page should be removed, right? So based on the future references we used to remove the existing page in order to load the new page, right? But in this algorithm we're going to look into the past instead of future. So that's make this algorithm very much useful for the practical implementation purpose, because past references are available with any process, right? So it is very much possible to implement this algorithm. Now let us look at the criteria of this algorithm. The criteria is we have to replace the page that has not been used in the most recent of the time, right? Which means we need to replace the page that was least recently used. That's why it got the name least recently used. Now let us look at the algorithm by taking the same reference string and with the same number of frames per process. So we take 3 frames per process and same reference string, okay? And as we discussed, the first 3 steps are common to every page replacement algorithm, because there are 3 empty frames. Now we got to fill all those 3 frames with the new incoming pages, right? Now the decision has to be made from the 4th page onwards. Now the page 2 is not in main memory, so we got to replace an existing page from the frames in order to load page 2. Now which existing page should we pick? We have 7, 0 and 1, right? So to make a decision, we need to look into the past as per this algorithm. Now which one is least recently used? Or in other words, which one was used a very long back ago compared to other page numbers? So compared to 701, 7 was used long back ago compared to 0 and 1, right? So we pick 7 and we remove 7 from the main memory. We replace page 7 with page 2, right? Now next page is 0. As 0 is already there in the memory, we don't do anything. We move on to the next page, which is 3. Now 3 is not there in the memory, so we got to pick one of those 3 pages in order to load the new page 3, right? So which one should we pick? 201. To make a decision, again we had to look into the past, right? Now which one was used long back ago compared to the other pages? 0 is used recently and 2 is also used recently compared to 1, but 1 was used long back ago compared to other pages. So we remove 1 and we replace 1 with 3 here, right? Now next page 0, it's already there in the memory, so there's no page fault. We move on to the next page, which is 4. Now to load 4, we have to pick again one of those 3 pages. So let's see which one we should pick. Again, from here we need to look into the past. Now 0 is used recently and 3 is used recently, but not 2 compared to 0 and 4, right? So we remove 2. So 4 replaces 2. And the next page 2, again this 2 is not available in main memory, so we got to pick one of those pages. Now if you look into the past, 3 is least recently used, so we remove 3 and we replace 3 with new page, which is 2, right? And it continues. Now with this approach, we get only 12 page faults. If you remember, for the same reference string with the same number of frames per process, FIFO gives us 15 page faults and optimal algorithm gives us 9 page faults, whereas LRU gives us 12 page faults. So LRU is like in between FIFO and optimal, right? So we would say LRU is better than FIFO but worse than optimal page replacement algorithm, right? But as optimal is not possible to implement and LRU is better than FIFO, so we go with LRU most of the time, okay?